Hello everyone, today we're gonna do a live streaming to showcase you how to install the newly created python-entsoe library to query and analyze data from the European ENTSO-E platform, which contains the information of the TSO, the transmission network operators that in Europe. The outline for today's tutorial is based on Datons Stories, which is programming stories with data, in this case with the energy sector, concretely European data. You can see all of the streams we have recorded so far in this web application, datons.com streams. Here you can see the historical that we have showcased, data from the Energy Administration in the US, also for time series and many other topics, as you can see in this catalog. If you are interested in working with us to develop custom solutions for your business or your team, you can give us a call by clicking here and have a discovery on how we can collaborate together. You can see my time slots, you pick one of them and we see if we are a good fit and meet which projects you're working on. So why European energy data matters? Because there are more than 35 countries having the information of the energy systems into this platform. It's public data, and we've got a REST API whose responses are in XML that we can process, query using Python by simplifying how we query the information. In this website, you can see all the information in charts like this map. If we click, for example, in the north of Italy, here we can see some information of the total loads and also the forecast for tomorrow, as well as many other indicators that we see here, generation, transmission, many others. So this analysis will apply in Python, dollaring first the data and having more simplicity and control over the information and more automation. So the problem is that European energy data into Python isn't straightforward. The responses contains code like 10 years for Spain, REE, which is the acronym for the Spanish TSO. So it's very complicated. Instead of querying the information with area Spain, we need to place these codes that you see on the screen. Or also, if we want some specific data, we need to use codes like A62. It's not friendly to use in a programming environment. The documentation has been greatly improved, although it's a bit fragmented from my point of view. The time zone, there are some rate limits, paginations, so all of that can be handled through the Python library, which in very few lines of code, we can have it. The data domains we've got is day ahead, intraday, prices, generation, mixed by country, per plant generation, output cross-border. There are many things that we can query with this library. Here you can see some examples where we will set up the token. I'll show you later how to set it up. Then from the client, we can access the generation mix with these simple codes. We specify the area, also the starting and end time, and we get the information into a data frame. Now, if you want the prices for the day ahead, we apply the same reasoning. As you can see, there are many similar parameters, and also cross-border flows, as you will see later. So today, in the tutorial, we'll cover many practical cases. First, we'll set up the library, installing it, the token with ENTSO-E API, and applying our first queries. Generational mix, day-ahead prices, cross-border flows, per plan outputs, and visualization. And also, we'll do a Q&A before after I explain you these practical cases, which the code is already published in GitHub. I'll show you later how to access it. And then I'll answer in live streaming and program all of the questions you've got so that I can get feedback on also what needs to be improved from the library. The tech stack will be Python, python-entsoe library, pandas, plotly, and Jupyter notebooks. So without further ado, let's get started. Meanwhile, when I develop the code, etc., and you don't understand something, please put a comment, and later during the Q&A, I'll recap on the most important questions so that I can showcase you an answer to them while programming. Okay, so 1 second first because I don't know. Let's go. Journey. I think it's okay. Journey. I'm checking if the streaming is going well in LinkedIn. All right, so everything's set up. So right there, the comment is working. So let's go. Okay, so first things first, we go to the official library that I created, whose code is all in GitHub. You can access it through this URL. And I'm gonna make it very friendly to use, beginner mindset, step by step. Now GitHub is taking time to, yeah, there we are. So to work with this library, there are many ways. I'm gonna show you the most straightforward. If we create an account in GitHub, let me do this in another browser. In case you don't have Python, you can download it. Everything automated directly from GitHub. So in here, we go to github.com, Datons python-entsoe. And if you don't want to install any program whatsoever, you can use the computer power from the code spaces. So inside this repo, after you have done sign up in GitHub, you can access the code spaces and launch a virtual computer to work on the code. So if I create the code space on main, it will set up the computer with the repo. And inside the repo, I have got some examples for you to use. Later on, I will show you also how to do this locally. All right, so here we've got the code. Let me increase the size. And here it's installing some toolings. This is some automations they do in GitHub when they set up the virtual computer. Now that we have it, we can close this. And here I have set some examples for querying balancing power. It's all the code there. You just need to execute and it will be done. When you set up first the code space, it will ask you to install the Python extension so that it can recognize better the tools to work with this virtual computer and VS Code. So you click on install, the recommended options. And now here we can execute. Also, let me put some icons in the folders. Okay, so now we can see better the structure of the repo. So here you can see that we've got the documentation, examples, scripts, the SRC, which is the code inside the library to query the information from ENTSO-E. Now, to work with the code at first, you should work with the examples I have prepared. Let's go with the balancing. Here to execute, we simply press the play button, and here is going to ask us to install some programs. We can execute. They're asking me what is the difference between this repo and the ENTSO-E.py that already exists. I'll cover that in a second. So now when they request me to install all of this, I can use the Python that has been installed by the virtual computer. And here is executing, but it's telling me that I don't have some libraries installed. Anytime you get any of this error, you go up here, pip install, and the name of the library. Of course, there will be many others, like Plotly, we don't have it installed because we haven't done so yet, and from the ENTSO-E library. Remember that this is a blank environment, so we need to install the libraries if you don't have them. So once the library has been installed, we can remove this cell because it's already installed in the system forever. We execute again, and now the error is telling us for Plotly. So we do the same, pip install Plotly. Now we execute again with Control Enter, and the error is now in ENTSO-E. So when I go to install ENTSO-E, I cannot put ENTSO-E because that's not the name of the library in the repository of packages pyp. If I go to python-entsoe pyp, this is the library they mention in the comments, which is another library they used. I can put, let me open it. And here we see the example of the prior library that existed. And now let me show you the library that I had created. So pyp, Python, ENTSO-E, and here we got it. Now, if I put this into split screen, we can observe the differences. In the ENTSO-E Py, you can observe the pattern of the application of the library. You import the client. This is the same that we do in our case. We import the client. We initialize it with the API key. The same here, just taken from the environment. And here is the thing, that there are many automations we've applied. For example, the ENTSO-E the other library, they require you to apply the timestamps using these objects and specifying the time zone. In my library, by default, the time zone will be of Brussels, Europe. So we don't need to apply a lot of code to get the same result. As you can see here, we simply put the dates of the start, the ends, and then we get the result. There is no need to specify this PD timestamp object, and neither the time zone because it's already automated into the library. Now, the second difference that you can see here is that in the other library, the pattern that they have designed is from the client, you can query any function. You have them all accessible. And again, these are ways of structuring the digital concepts of the API into the library. They chose an approach which is function-based, flattened. Flattened means that right after the client, you get all of the functions available. In my case, I have done it structured, meaning that from the client, you access the data energy domain, which can be loads in this case, and we get the actual, which is actual prices. If you go down, here you will see in the API reference how for each data domain load, we can get both the actual and forecast. We can get the prices with the day ahead, generation with the actual forecast, install capacity, and per plant. So now you see that there is a structure on how it's first the client, then the data domain, and finally the inside the data domain, which type of data you want. Do you want the actual data? Do you want the forecast? Do you want install capacity? Do you want the power per plant? And this is what you get based on the client in the data domain you choose. Here we can see transmissions, cross-border flows, schedule exchanges, and many others. Another thing is that they are using these market agreement types with the codes. In my case, I am using, you can use both the code and the common name. For example, you can see here that we can query the information not yet done here. We'll see it later on the examples. But inside the library, I have prepared the mappings so that you can observe, for example, which are the equivalences of the code. So that instead of using V01 when you develop the code, it's not easy to understand. Instead, you will put biomass so that you get what it means right away inside the codes. If you go to mappings or inside the codes, SRC, mappings, here you've got the list of equivalences from what we normally understood with the codes, example here to the left, to what ENTSO-E understands in the internal core of the API. And these are some of the automations we have applied to the library. Also the equivalences on country names. Then we have got the document types for the type of generation, the process types, the technology, and also for the technology, all lowercase, so that maybe it's easier to write for you. At the end of the day, all of the results are human readable ones that you can plug right away into the charts. So it's very comfortable, as you will see now. Okay, let's go back. So here, if we try to install the library with pip installed ENTSO-E, we will get an error because this is not how the library is codified into the PyP registry. As you can see at the top, we've got pip install python-entsoe, and this is how we shall apply in GitHub. So we copy and paste, execute again, and there we have it. Nord. Oh, I forgot an error here. Because in this computer they prepared, if I go to the terminal, they have installed a Python version which is lower than the required by the library. So that's why I'm getting this error. And now I have just asked the chat of VS Codes on how to fix it. They will tell me how to upgrade Python, which I mean they already tell me here. So I can do open terminal or focus terminal. No, but I can do it here too. Sometimes when you execute code that is meant to be on the terminal, you need to put the exclamation mark. So now we should have the this way. The problem, okay, I see it here. Let me set it back 1 second. I'm gonna create a Python file here. So when I execute this function, they create this folder, and I should be able to select the environments. And when I go back, I should be able to install the ENTSO-E library with UB. having problems all the time. I'm gonna do it on my local computer because I'm getting many issues here because of the setup. Later I will record a video and put it on the same live streaming so that you can follow up better. Because in this virtual computer from VS Code GitHub, I should have prepared a version with 3.13 before so that I could work with it, because in this case they are not allowing me to, or maybe yes they do. No. No. Okay, never mind. So I'm gonna go back to here. I'm gonna take this folder into my computer locally. I download the zip. And now from here, I uncompress the folder, open Visual Studio, drag and drop the package, and finally here I should be able to go in balancing, execute with the environment. However, in this case, to work better, I should open the terminal, and here I will run UV sync so that we get the virtual environment specifically for these projects. And when we select the kernel, we go to python-entsoe from the virtual environment. We click on yes, and here we execute again. Now, the library has been installed. We get an error because we are missing the API key. To get the API key, we need to go into ENTSO-E Platform, Transparency Platform. Inside, we send in, put the email, create an account if you don't have it, and from my account, we get the API access, generate a token, copy the token. In VS Code, we create a file called .env, and here we need to specify the ENTSO-E API key. Now we close it. If we execute again, it's not going to work because we need to restart so that the VS Code can track the changes from the .env file. So after restarting, which if you don't see, it can be here, you execute again, and now the client has been initialized. So now we are ready to query the information from ENTSO-E library. If we go to the client with the dots, we can see that we can access generation, we can access loads, we can access the prices, and then inside each data domain, we can observe which type of information we can get. Day ahead, area, and the many others you see here. Now, to work with this library, I have prepared these notebooks so that we can query the information. For example, from these two dates in France, we get the imbalance prices. Here with the head, we get the first five, but if you want to see the whole data frame, we can create a new cell in between, and then we go with the prices. And here we have the daily, no, each, for France, the imbalance prices and the difference between each one of them here is the same date. So there might be some other data domain we need to fix in this case, because when we do the line, we get here the imbalance prices in the chart. And some of them, they are repeated. If there are some problems with the library, like this one, please take a picture, a screenshot, and if you go to the repository in github.com, you specify Datons python-entsoe, you create an issue, new issue, paste the screenshot and say, hey, when I queried this data with this information, I'm getting this hourly repeated, but I don't know how to differentiate them. I don't know if this belongs to something else. I will research why this is the issue and apply a fix to the library and publish it. So it should be solved, and then you can work with it. At the same time, if you're working with a library and don't know why these issues are happening, you can copy, open the chat, create a new one, and say, for example, on these results from these codes, why the library doesn't differentiate the hourly data or the records, because they are repeated timestamps, for example. And the chat will research inside the library for issues and try to execute some other tool to see if it can work, the solution. Although they say they are expected because they are from two directions, up and down, and we should get the column indicating the direction, regulation, and price. We can tell if copy the path, search in the library for a fix. All right, so meanwhile it's research, we can continue executing. Here we can see, for example, how we are querying the information of multiple countries for the imbalance prices, concatenate everything into a data frame. And here what I recommend to you is that if you want to learn what's the internal process of these examples, you can go above and paste the code so that you can see down below if the results, intermediate result, makes sense. And here you can see for each country the imbalance prices. And now here from these codes, it's the chart from each one of the countries. Now, price distribution histogram, imbalance day ahead. So these are all repeated analysis from the library. You have them all in these examples, generation per plant. You execute the codes. Here for France, we can get for each individual plant, which is the identifier. For example, here it means there is a fossil gas plant that generated 0 megawatts. Or maybe here is the third generation. Yeah, megawatts per hour. The same we have here for nuclear power on this hour, and the unit is called Blaise 2. The same for the rest of units. To get the API key, Mohammed, you have to go into the ENTSO-E Transparency Platform. And here, pay attention to the link because it's not this one, but this one. You sign up, and after you sign up, you go to My Accounts, Web API Access, and here you generate the token. And then the code, you put it into the .env file. It's in the recording, so you can come back and grab it. All right, so now for the rest of the executions, here you have all of the codes. We are doing more of the same. Here we are aggregating the information, nuclear plants in France, a line chart, so different ones. Here they are gas plants, different aggregated by field type, using generation units higher than 100 megawatts of installed capacity. Then in generation, the same, you can click in run all and everything can be executed. You see all of the examples. Here we get the generation mix from France, generation share, and many others. So I won't go into the details. You can execute this. If you don't know how to, please let me know in the comments and we'll get into the Q&A section. So I guess that many of you here know a lot about energy, maybe not so much about programming, but that's why we have this section of Q&A. If you want to know something that you can query with the library, let me know in the comments and I will program it for you using the resources from the library so that you can take advantage of it. The rest, also, if you've got doubts about programming in general, let me know in the comments and I will address them too. About programming in general. No questions. So I guess that everything is clear. That's good. Okay, guys. In any case, as a recap of what the library is and how we can proceed with the next steps. This library is available in GitHub. So again, if there is anything the library is missing when you use it or you don't understand something, create an issue, let me know what's the problem with a screenshot. That should be okay. I will fix it, and when I fix it, you'll get a notification to install the library again and reuse it. The problem I've had today with the installing the library in this GitHub code space, it's been a bit messed up because of the library Python version. But don't worry, because I'll publish a shorter tutorial so that you can get right away with the solution without interruptions in your own environment. And I think that furthermore, I will create a proper code space so that you can run this library without any issues like we had today. I'll put the link in the description of the video that is in YouTube, because remember that all of the streams we are doing, they are being published in YouTube. So for today, we've got Datons Stories, 9 European energy data, and here in the comments you can also let me know if you get any issues with the library. And finally, if you want to take a course with me on learning how to bytecode, because from the other streamings that I did, they were more about developing the solutions of the library, but they made me a question in the in LinkedIn, and I'm gonna show you how I work with to answer these problems. So, for example, David asked me if this was possible to do it. So I can just copy here. I go back into the Python code, and with the chat, I can ask in a new one. How to address this question in a new notebook using the python-entsoe library. And if you apply it, the same chat that has the ability to look into the code, it will understand how to access the information and then develop the practical case. So you don't need even to program with the library, like creating the cells here, but instead you can right away prompt what you want, natural language, and have the chat to develop it for you, as it is doing here, creating a generator level in Germany for the analysis. And if we see in the examples here, the file is being created. We can keep the changes, although it's fixing something. Let it wait. We keep the changes. And here we execute. Since the library is already capturing the API key from the file, we don't get any problem. And here it's downloading the information from Germany per plant. We execute. Then we fetch the information, but they tell us this, that there is no actual generation. So this error can happen because they are not executing the codes. So we can, for example, here go into the chats and ask, we are getting these errors. And the chat, since it has the ability to execute, it can help us to debug. Let me see. Okay. So it's very interesting these days to develop these tools, because when you want to apply as a user that you are not interested in building the library, but just in applying the functions from the library, you can, with natural language and the library to the side, keep asking so that it can fix the issues that you may have. So let's execute. We go back. And the problem is that there is not matching data. Yeah. But in these cases, instead of using the notebooks, it's better to work with the Python scripts so that the chat can even execute the code and research by itself. So I'm gonna tell execute the code yourself with python scripts.py so that you can debug and fix properly. It's asking questions. Yeah, it's for the location in scripts. Let's do it. Mohammed, if you cannot find the API section, maybe give me 1 second. In the transparency, you should have it here. However, if you have problems, you should send them a message, because sometimes they have to enable you the access to get it. So that might be an issue, but it should appear. Now, Piyush is asking how we can access generation data from a specific wine farm. So if we go into the Python code, here we can submit, and I will ask that in a moment. I'm gonna use another chat agent so that we can specify, create a Python script for it. The question from Thomas is more technical. It's asking about ancillary services, in particular FSRR and AFRR prices and activations planned to be integrated. Let's ask right away. We can create a new conversation. Let me do it here. create a Python script to query this information. Let me check in the other chats. Yeah, Mohammed, I think for ENTSO-E to enable you the API access, a couple of days needs to pass. Otherwise, you can send them a message so that they can give you the API key. I had some other people who had this issue. If you go to the accounts, and here in my accounts, you should see these preferences, web API access. But if you don't have it, I recommend you to reach out to them into their email. Maybe contact us here and ask why you are not able to see the get of the API key. Let's execute. Thomas, in here, the chat, they developed this function to query the information of the FCR services. However, when they query it using the function of the client balancing and the parameters, they are getting some errors. But here in the chat, it can debug the information on how to access the information because it's getting the error. This is one of the advantages of working with AI if you with the proper tools. Because I think your question is not addressed into the library. So we might need to add that information into the structure of the API in the library. Yeah, to get the API key, Mohammed, you should have this code .env file. Ensure that you create the .env file in the root repository you see here. So in here, new file and .env. And then inside, you need to put this key. If you use this one, it will work. But I will deactivate later because they might see that many people are using it. So, Thomas, to your question, now the chat, after having researched online in GitHub the source library ENTSO-E Py, they've got the information on the FCR. So they understood it must be A52, not A46, which is MFRR. And here there are some rules of the API that they need to control. So now they are doing this into the file. If we go again, ancillary services, here we observe the changes, and now they should be able to access that information. But yeah, some of them, they don't get the data. Good. Now we are having the information here, Thomas. For some records, like the Netherlands, apparently. After the chat has worked out a possible solution, I'm going to create a notebook so that it can be easy understood how to query the ancillary services. And if it's not on the library, I will add it. As a reflection, um, these days that we are developing code with byte coding, I mean, you should know what you are developing. However, sometimes there are many rules, like in this API, that it's almost impossible to review each one of them. You should have a team to review them. So instead of blindly trusting the AI to develop this, what you should do is enabling the tool to execute the codes in Python scripts, because the Python scripts in the chat, you get the results. And from there, the chat interpret the results to know which are the ways to query the information that you want. And this is what exactly is doing now. And because of this, we are able to assess the rules, see the patterns, and then put them into the library. So here we can see the results. They have been saved into this function, and we can, for example, review the value, currency, quantity for the FCR, then the AFRR. I don't know, Thomas, if in these files you are missing something like units or some other information. I think this is good to go because I don't have the detail. I don't think they have got the detail per plant on these data categories, although they might have it in another endpoint. Yeah. So here they got this capture. To the chats, what I first want to understand is the capability of requesting the AFRR and the FSR, also the MFRR, into the which are indicators from the energy sector, like also different markets. Is the library ready to get this information? And they say, not yet. These queries just live on the scripts. However, the chat, now that it knows the information, is going into these codes and is updating the information of the processes so that I can use them right away with the library. Now they are testing. And with these codes, I should be able to get the information. There we have it. So now we run the test again to see that everything we had previously developed is okay. I'm gonna create a notebook with this query so that we understand better how they work inside the library. Regarding the question from before, from Piyush, I can see here on the wine farm, we've got the example. And here, basically, we are defining which type of wine farms, which can be onshore, offshore. And then inside the generation, per plant, we ask for the country specified. And then from here, we get the data frame. So it's also possible to develop it. And you will get the aggregations. So now they have the ancillary services. Here they are executed. And here we get it. The contracted reserve prices, FCR. Then we get it for the Netherlands. Then we have got others, MFRR, all in the same table. After having requested them with a for loop for the Netherlands. Here is more granular as we get it start ends. Yeah, so mostly anything that you can imagine that is on the ENTSO-E data platform. Now with this library, you can query it with the Python code. Even if you don't know how to code, the AI can introspect the way to query the Python code and get the information. And here you can get the charts to analyze the data. Regarding the recording, Evelyn, yes, I will publish it in datons.com. So if you go to the website, datons.com, into streams, here, Datons Stories, it will be published right after the session in YouTube. So you can also go back into I will share the link into the chat, and there you have it. All right, guys, so it's been a pleasure. I think all of the questions have been addressed. If you want to learn more about other practical cases that they are not there, remember to request in the issues section of GitHub. I'll do my best to update the library and have those results for you. If you created the issue and I get the solution, you'll get a message into your email linked to the GitHub account so that you can apply the same concepts into your practical cases. Now, if you want to stay tuned with the content I am publishing every week, also I'm launching some courses to help you apply all of this knowledge and libraries to your own analysis, but using AI so that you can multiply the time you spend in one practical cases, and instead of working in just one practical case, you can take advantage of AI to do them, for example, at the same time and develop the system structures to have the results in two batches, like from one command, you can generate multiple analyses so that the AI can analyze all of the results for you at once. If you want to stay updated with the content that I am publishing, you go to datons.com, and here you get the updates by leaving your email. So it's been a pleasure. Thanks for staying with me here today. I hope that you've learned a lot, and we'll see you next time.